All right, as we arc through our next few talks, we're going to focus on geoscience education. And our first talk here is GeoSPACE, Mission Control and Astronaut Exploration Field Course Teachings by McKayla Meier.
Hi, everyone. Thank you so much for coming to my talk, and thank you guys for organizing and hosting this session. My name is McKayla Meier. I am a doctoral student at the University of Florida and the virtual mentor for the GeoSPACE program. Today, I want to talk with you guys about the GeoSPACE program and how we use this mission control and astronaut-based assembly to run our field course. So what is GeoSPACE? GeoSPACE stands for Geoscientists Promoting Accessible Collaborative Education. For us, we address one of the many barriers within the geosciences, which is field courses. By that, I mean we have a 10-day field course that focuses on making our geosciences inclusive, diverse, and accessible. And you might be asking, how do you do this? I think we should first address who our students are for GeoSPACE because they are obviously a major part of our program. The students of GeoSPACE are undergraduates and graduate students who applied through this process. It's basically an application. You have to be accepted into this program. We have students from all over the world. In particular, our students have an interest in volcanology, geophysics, geotechniques, planetary processes, or similar fields. In particular, we're looking for students that come from diverse and unconventional backgrounds because we wanted to create a program for students who don't quite fit the mold for our traditional field courses that we offer in modern day. This is students that have maybe accessibility challenges or students who have outside of education responsibilities or any student who don't fit the niche group of individuals who can attend physically, mentally, and financially strenuous field courses that we offer. And so our GeoSPACE approach uses two aspects to it. It's a dual participation method. Our first one are in-person students, otherwise known as our astronauts. Our astronauts have the ability to explore analog locations, and we use this as an emphasis on accessibility for our students to be able to go to these geologic places that maybe they haven't thought of or couldn't go before without this program. If you'd like to hear more about this, check out Dr. Anita Marshall's talk, actually later this afternoon, in session T24 in room 328 at 3:30 today. The other side of this is our remote students, otherwise known as our mission control. Mission control has a couple different tasks where they essentially analyze a wide variety of planetary data sets to understand the geology of the site. And with this information, we can create exploration plans for our astronauts when they go inside the field. For this talk, I plan on focusing mostly on the mission control remote aspects of this course. And so our field course structure is highly important to making sure that our remote portion works, and we can separate it into three separate sections. First, our students have the ability to investigate our geologic sites using a variety of data, including imagery, spectral, and physical data sets. Our students then work together as a group to decipher what the origin is and what processes are occurring at these sites. We can see this here in this Google Earth image, where our students were able to decipher that there's this major tuff ring with also this subsequent cinder cone chain, while addressing that there was groundwater magma interactions specifically at this location. And from this, our students come together as a cohesive group to create these briefings or an understanding for how astronauts should explore in the field. Briefings typically include what the geology is of this Earth site that they're going to, how does it relate to other planetary features, and what questions are driving their exploration for our astronauts to answer. And so where are our Earth sites? Because obviously there's many different types of volcanism across Earth. We focus specifically within the San Francisco Volcanic Field, as well as other features around the area within Arizona. In particular, we're looking at volcanism such as cinder cones and lava flows, spatter ramparts, and tuff rings. Additionally, we look at other features within Arizona. Just like Dr. Kring pointed out, we have this awesome location of Meteor Crater, within Arizona that is a perfect place for where we trained our astronauts and still do to this day, as well as stratigraphy-rich locations such as the Grand Canyon, and understanding how these different geologic processes all occur within this relatively small-ish area. And so for our Earth sites, we then use a variety of techniques that are accessible for our students and are actually user-friendly. So our first set of what we look at each of these sites is with Google Earth. Google Earth comes in an application or web browser, as probably a lot of you guys know. This is really important for our different types of operating systems that our students use. Our students can then analyze these sites from a 3D perspective as if they were there in person with true color. They can also then do topographic analysis from there. After this, our students then have the ability to use JMARS. JMARS is an application that is compatible with most operating systems and has a wide variety of data sets within it already. Additionally, we created a shared database for our students to access with a lot of data for them to basically pick and choose what they're most interested in. This data includes LIDAR, ALI, Landsat, Aster, TIMS, and Sentinel data, essentially a whole bunch of different types of physical and spectral data sets. Examples of this can be seen here, such as our false color or our band ratios, or even to the point of looking at vegetation index on these lava flows. This is SB Crater for reference. And from these Earth sites, we also want to be able to have this type of communication with real-time access. So our students are not only viewing them in this remote sensing perspective on their own time, but they're also able to get this real live feedback from people. So first, we have our astronauts who are out exploring these sites on a variety of different days. And the great part about this is that we use consistent communication through Discord with our students. Over Discord, they can talk about, updates of the site, questions they have that advance from their already driving questions, or even get pictures of these different locations as a feedback. We additionally have these live streams that we have as a rover simulation. And what I mean by rover simulation is that we have basically a person that acts as a rover that's able to go out there and follow directions as if our mission control is giving them, such as, hey, take a picture of this, or hey, take this sample, that type of scenario. If you're more interested in this, you should check out Yesenia's abstract. Her talk was this morning, sadly, but awesome abstract about how we use this communication system for GeoSPACE. And so next, we want to apply this to our planetary data sets. How do our Earth features fall into our solar system overall? And so why not look at our nearest neighbor, the moon? And so we use tools such as JMARS, LROC Quick Maps, and NASA MoonTrack to look at the moon. And the great part about these web browser tools is that they're not only highly user-friendly, but they also contain a very wide database of data sets for all of our students to explore and find out what is most of interest to them. Okay, and so then we want to look at what volcanic features on the moon are our students exploring. For example, we could say, look at the potential silicic volcanism on the moon at the Poseidon domes, or look at, lava transport. Additionally, with the upcoming Artemis missions, we find it so important that our students understand why we're going to the moon. And so we do an exploration activity of looking at the South Pole, looking at the geomorphology and the geology of the location to identify what are we, hopefully, going to learn from our next missions of Artemis. And as a similar history, or potential similar history to Earth, we look at Mars and its features. To do this, we use tools such as JMARS, Google Mars, and NASA Mars Track. As I said, there's a wide variety of databases on here that our students are able to analyze, and the great part about it is that it's all high resolution and they can really pick what they are most interested in. And so our students want to look at things like the volcanic features, such as comparisons between Earth and Mars. We can do this at Ulysses College when we're looking at lava flows and cones in comparison to, say, SP Crater. Or we can look at features such as Valles Marineris that looks oddly similar to the Grand Canyon but has a completely different origin history than what we're actually seeing between the two planets. Additionally, our students have an activity where they look at Jezero Crater and the Perseverance rover samples, where they look at if we're doing these rover observations, they're collecting these samples and they're analyzing this data, what can we really use these rover tools for in the future, and how do these missions expand from there? And so, as an overall, let's talk about the key structural steps to this remote field course from what we've learned over the 2 years. Predominantly, the main things that are highly important are communication and organization of the course. This really helps our students be able to stay on track while also communicate their needs as well. And to do this, we use asynchronous and synchronous activities. This helps with our students that especially have outside of class responsibilities that need to work on their own time, and so they have individual and group projects that they do get together. So before the course, we have a variety of things that we also try to do with our students. In particular, we give them information on what are the downloads they need to have for this course that they can already have on their computer. And we also introduce them to this interactive schedule. As with any field course, there's some variability, but it provides students with the necessary needs to feel prepared to go into this course. Additionally, we have several Zoom meetings for our students where we welcome any questions and have this environment where if they have questions or they need clarification on something, they're more than welcome to ask. And then in the introduction part of this course, it's really important that we highlight what the geology is that we're seeing and then go from there. So we start with an open introductory geology Zoom meeting, and we also have software video tutorials that our students are able to access, such as how do you work JMARS or how do you work Google Earth. And then we also have what is the data that we'll be using during this field course and explanations of what each of them means beforehand. This helps our students prepare and also feel like they can use that as a resource as they're going back. And so our daily structure can be broken up into 3 parts. Specifically, if we're doing the morning time, we have a briefing in the morning, as well as instructional videos and documentation on what the tasks are for the day. Typically, our remote group is on a different day than our in-person group because we're preparing for these sites. And so we have these instructional videos and documents that really outline what they'll be doing during that day, even if it's on a different topic. And in particular, it's really important that we record all our Zoom meetings because a lot of our students can't meet those times because they have other responsibilities. And so students can go back and watch the videos if they couldn't make it, or if they just need clarification on these topics. Additionally, something that we've noticed this year that really helped is that we have an ongoing inclusive note sheet that our students are all able to add to progressively. Instead of having your own field notebook, you can have a joint one with everyone. And then during the midday, we have a couple different tasks that we do to keep our students on track and feeling supported. In particular, we do individual and group check-ins during the middle of the day for our students and really ask how, as faculty, we can help our students feel better about what they're doing. Additionally, we have on-site live streams, such as our rover live streams, as well as specifically talks on research and career pathways that they can go to in the future. And then, as I've already mentioned, we have consistent Discord communication for those students that maybe don't want to hop on Zoom or just need a quick question answered. And then during our evenings, we typically have an evening debrief that's also recorded for our students to access, as well as evening office hours for our students that maybe couldn't meet in the morning, just need extra clarification, or trying to prepare for the next day. And so overall, from year 1 to year 2, we've had many bumps along the way of learning how to run a remote field course and how to mitigate these issues and find solutions for them. So in particular, this year we added a course credit option for our students, which heightened a lot of the anxiety around grades. And so to mitigate such an issue, we focus on having detailed written instructions and a schedule for our students to be able to follow clearly and feel like they can ask questions anytime. as well as over Discord if they are completely lost or something of the sort. Additionally, it's very important for us to set boundaries and expectations for this course because of how fast-paced any field course is. There can be a lot of anxiety and a lot of pressure for the students, so setting those boundaries on communication and expectations is very important. Additionally, we have changes of our challenges associated with our multiple operating systems, and so for that, we use an abundance of data as well as different programs where students can pick and choose what data is actually accessible and usable for them. And hopefully, we're eventually going to put together a remote desktop for our students to utilize so that we can mitigate some of the issues with having multiple operating systems. And so to follow up at the end of this talk, there's some main takeaways from the course, mostly that remote field courses are actually very necessary to making the geosciences an inclusive and accessible field for students. GeoSPACE and other courses can teach techniques that are actually applicable to careers further on. And if you have any more questions about this, check out Sean Thatcher's talk on Tuesday and Anita's talk this afternoon. Again, thank you to NSF, session chairs, and for all you guys coming to the talk. Yeah, that's fine.
Thank you. We'll need to move on to our next speaker, but we have a break coming up after this next talk if anybody has any questions for our speaker who just went. So thank you very much.